So welcome to Game Dev Math. For our first topic, we will be tackling about interpolation. Interpolation in games is a technique used to smooth out animations, movement, and other time-dependent transition by estimating values between two known points. It helps to create fluid motion and compensate for variation in frame rate or network latency in multiplayer games. Types of interpolation games. Number 1. Linear interpolation. Linear interpolation calculates a straight line transition between two values, where A is the starting value, B is the ending value, T is the interpolation factor usually between 0 and 1. For number 2, it is spherical interpolation. Spherical interpolation is used to smoothly rotating objects, especially for quaternions and 3D rotations. Cubic and Hermite interpolation. Cubic interpolation uses polynomial functions to create smoother transitions with acceleration and deceleration. Hermite interpolation, Catmull, Rom spline. Hermite interpolation allows control over tangents, giving better ease and outs effects. Catmull-Rom spline, a common method for smooth path interpolation. Animation interpolation. Modern animation engines use interpolation to transition between animation keyframes smoothly. This includes Bezier curves in between twinning. Why use interpolation in games? It is used to smoother animation and movement, compensates for frame rate variations, improves multiplayer synchronizations, and enhances realism in physics and camera systems. For our next topic, it is about transforms. In game development, transforms refer to an object's position, rotation, and scale in a 2D or 3D space. Every game object, such as a character, camera, or environment asset, has a transform component that defines where it is, how it is rotated, and how big it is. The three key components of a transform. Position or translation defines where an object is in the game world. In 2D games, it's typically represented as X and Y. In 3D games, it includes a Z-axis, and so it is X and Y and Z. Moving an object means changing its position values. The next one, rotation. Determine how an object is oriented in space. Can be represented using Euler angles, XYZ degrees, or quaternions for smooth rotations, commonly used for character movement, aiming, or camera motion. Next one, scale. Controls the size of an object, typically represented as scale X, scale Y, and scale Z. Scaling uniformly, same value for all axes, keep proportion intact. Used for resizing UI elements, enemies, or environmental objects dynamically. Transforms in game engines. Most game engines like Unity and Unreal Engine use a transform component that automatically manages these properties. Example in Unity. Example in Unreal Engine. Local versus global or world transforms. Local transform, position, rotation, and scale relative to the parent object. Useful for hierarchies. Example is sword attached to a character. World transform the absolute position, rotation, and scale in the game world. For example, a camera might have a local transform relative to the player's head. A gun might have a local transform relative to the player's hand. Transform hierarchies and parent-child relationship. Objects can be children of other objects. A child transform is relative to its parent transform. For example, a character's hand moves when the character moves. A car's wheel rotate when relative to the car's body. Uses of transform in games. Moving objects, rotating cameras and characters, scaling UI elements dynamically, creating animation and cutscenes, implementing physics interactions. The next topic, vectors, using dot and cross product. Vectors are essential in game development for handling movement, physics, and 3D transformations. Two of the most commonly used vector operations are the dot product and cross product. Dot product measuring similarity and angles. The dot product is used to determine how similar two vectors are in direction. Where A and B are two vectors, A and B are their magnitudes or lengths. How to use the dot product in games. Checking if two vectors are facing in the same direction. If that product is greater than 0, vectors are pointing in the same direction. If that product is less than 0, vectors are pointing in the opposite direction. If that product is equal to 0, vectors are perpendicular or 90 degrees apart, determining visibility or field of view, used to check if an enemy is in a player line of sight. If the dot product between the player's forward vector and the vector of the enemy is above a certain threshold, the enemy is visible. Lighting calculation. The brightness of a surface depends on the dot product between the surface normal and the light direction. Number 2. Cross product. Finding perpendicular vectors. The cross product calculates a vector that is perpendicular to two input vectors. It is useful in 3D calculations. How to use cross product in games. Finding perpendicular vectors. Used for determining the surface normal of a triangle in 3D graphics, important for lighting and collision detection. Calculating torque or rotation axis. In physics-based games, cross product is used to determine how forces should rotate objects, determining left and right vectors for movement. If you have a forward direction and an up direction, you can find the right vectors using cross product. Dot product versus cross product. When to use what? Dot product measures similarity checks angles, visibility, lighting calculations. Cross product finds perpendicular vectors, determine the rotation axis, calculates surface normals. Thank you for listening.